we will see what is root locus technique, how to plot a root locus, what is the concept behind it, and how to analyze the system. Okay, how to analyze its stability or instability. Okay, now first we'll understand the concept of root locus. See, I am saying root locus, that means I am plotting the different roots on changing of some variable. Okay, let's take a general system which RS is the input, plus minus negative feedback system, a unity negative feedback system, K upon S into S plus A. So this is a unity negative feedback system. In this, my CS by RS is equal to K upon S square plus AS plus K. Okay. Now, we always have to look for the characteristic equation of this transfer function. So in this case, characteristic equation is equal to S square plus AS plus K equal to 0. Okay. This characteristic equation will give me the roots. These roots are nothing but the poles of the system. So if I find the root, suppose S1 and S2, which is equal to minus A by 2 plus minus the root of A by 2 whole square minus K. Okay. Now we have reached till this point. Now the parameter which can be varied here is either A or K. Okay. Generally, now in root locus, I will change the gain parameter. The gain parameter is nothing but K. Okay. The coefficient of S, whether it is A or whether it is some other, I will not change unless and until it is specified. For finding root locus, I will change my gain parameter K. Now if I plot a root locus for this, okay. Now when K equal to 0, my one root will lie at origin, another root will lie at minus A. Okay, because when K equal to 0, S square plus AS equal to 0, S into S plus A equal to 0, S equal to 0 and minus A. Okay, now this is for the first case when K equal to 0. Here also K equal to 0, this also K equal to 0. Now if I increase my K value, now there are two things. One root locus depends from K value 0 to infinity. Another root locus which is called complementary root locus, which is for K equal to 0 to minus infinity. Okay, we'll see that also. What's the difference between the root locus and the complementary root locus? Now if I increase the value of K, okay, then what will happen? S square plus AS plus K will equal to 0, for which I have found my roots like this. Now in this, if I increase the roots will try to come closer and closer and closer. Okay, this root will start moving towards this root will start moving towards this. At some point when K value is equal to A by 2 whole square, the root will be, this is at the middle of this, so it is minus A by 2. This will happen at K equal to A by 2 whole square. After this, these two roots or poles will come at one position, and after this these two poles will move apart. The angle of departure of these poles depends on the number of poles arriving. Since here 2 poles are arriving, so angle of arrival in this case is 180 upon 2. Suppose if there are 3 poles are arriving at the same point, then angle of departure will be 180 by 3. So it will be 60, 60, 60 degree. Okay. So in this case, they will depart at an angle of 90 degree. And this value will increase up to k equal to infinity. Is equal to k equal to infinity. So this was a simple root locus which is plotted depending on the value of k. Okay. Now, from the previous root locus diagram, I have to note some points. The first one among that is root locus has 2 branches. Okay. One starting at, that means 2 branches starting at 2 open loop poles. That means root locus will always start from poles and root locus will always terminate at 0. In case if zeros are not there, then root locus will terminate at infinity. Suppose there are 2 poles and 1 0. Then in that case, one pole will terminate at 1 0, another pole will terminate at infinity. With increasing value of k from 0 to a square by 4, I have seen my s1 is equal to s2 is equal to minus a by 2. Okay, this was one of the points we have observed. With increasing k, still if it is increased, a square by 4 to infinity, s1 and s2 will become complex conjugate. Okay, so this was the another point. Okay, now I have seen that for this general block diagram, I can write my transfer function is gs upon 1 plus gs hs. Okay, so the characteristic equation is 1 plus gs hs equal to 0, which implies that gs hs equal to minus 1. Okay, so from this magnitude condition is gs hs magnitude is 1 and the angle of gs hs will be plus minus 180 degree odd multiple. This is for the root locus when k value is increasing from 0 to infinity. There can be another term, there can be another type of root locus which is called complementary root locus, which is for k value 0 to minus infinity. Okay. Now we will see the properties and the rules for construction of complete root locus. Construction of complete root locus. Okay. Just write property number 1. Okay. Property number 1 says that if my gain equal to 0, if my k equal to 0, then the points on the root locus are at the poles of GS into HS. Okay. See, suppose if I have my characteristic GS into HS something like k times of S plus 1 S into S plus 2 S plus 3. Okay. Now for this characteristic equation is 1 plus GSHS, which will be S into S plus 2 S plus 3 plus k times of S plus 1. Okay, which is equal to 0. If k equal to 0, then S into S plus 2 S plus 3 equal to 0. Equating this equation means that I am finding the poles of GSHS. Okay, so this is the first theorem or first property for k equal to 0. Now second, similar, if we have seen for the k equal to 0, if k equal to infinity, then what will happen? If k equal to infinity, then the points on the root locus are the zeros of GSHS. Okay. Then the points on the root locus are at the zeros. We'll take the similar example. GSHS equal to k times of S plus 1 upon S into S plus 2 S plus 3. So 1 plus GSHS can be written as S into S plus 2 S plus 3 plus k times of S plus 1 equal to 0. K equal to infinity means S plus 1 equal to 0. So S equal to minus 1, which is the 0 of GSHS. Okay. This was the third point. This was the second point. Sorry, you have missed the video when I was writing. If k equal to infinity, then the points on the root locus are at the zeros. That means the root locus will reach at the points at which when k equal to infinity are the zeros of that point. To prove that point, I'll again take GSHS equal to k times of S plus 1 S plus 2 into S plus 3. So writing the characteristic equation for this 1 plus GSHS, it can be written like this. If I put k equal to infinity in this, I will left with S plus 1 equal to 0. S plus 1 gives me S equal to minus 1. S equal to minus 1 is nothing but the 0 of GS into HS. So that means at k equal to 0, it is at the poles. At k equal to infinity, it will reach 0. So root locus will start from poles and it will terminate at 0 or infinity. Okay. Now property number 3, it is related to the number of branches of a root locus. Okay. So the number of branches in a root locus is equal to the order of the polynomial. Order of the polynomial is also equal to the number of poles or the number of roots of the equation, characteristic equation. Okay. So for example, same 1 plus GSHS, which is equal to s into s plus 2 s plus 3 plus k times of s plus 1 equal to 0. The number of branches here is 3. Why 3? Because the order is 3. Okay. Fourth property. This property related to the symmetricity of the root locus. Okay. So as per the symmetry is concerned, root locus is symmetrical about the real axis. If it is symmetrical, since the poles are exist always in complex conjugate pair, that's why this symmetrical nature exists. The real axis. Okay. Fifth property. To see for the previous two theorems, if I have my GSHS is equal to k times of s into s plus 1 s plus 2, then if I plot the root locus of this, then I have s equal to 0, s equal to minus 1, s equal to minus 2. Okay. Now if I draw the root locus of this, I'll first draw it to tell you how it is symmetrical. These two poles will approach each other and at some point they will collide and then they will break off. This pole which is there, it will move and go towards infinity. Set k equal to 0. So since it is symmetrical, the roots at this point and this point occurs in complex conjugate pair, so that's why it is symmetrical about the real axis. Okay. Now fifth one will be asymptotes of the root locus. Asymptotes of the root locus. First, how many asymptotes does a root locus will have? If there are m zeros, and n poles, then number of asymptotes is equal to n minus n. Okay. Now the angle of asymptotes is equal to 2k plus 1 pi, that is again odd multiple of pi, upon number of asymptotes present. Okay. N is not equal to m. This is for the root locus. Now if you want to find the sixth property in this, same for the asymptotes. When the asymptotes will intersect the real axis, what that point is called? That point is called centroid. Intersection of asymptotes. Okay. The intersection point, which is called centroid, it can be found by summation of all the finite poles minus summation of all zeros upon number of asymptotes. Okay. Suppose, for example, A poles are given by -2, -3, -3 plus 4j, -3, -4j, and zeros are given by -1, -2, -4. Then centroid in this case is equal to, number of poles are 4, number of zeros are 2, -2, -3, -3, -3. Because if we take plus 4j minus 4j, they will cancel out automatically. Minus of -1 -4, okay, upon 4 minus 2. So the sum of this is 9 minus 11 minus 11 plus 5 upon 2. So this is -6 upon 2, which is equal to -3. So the asymptotes will intersect at -3, okay, in the root locus. The seventh one is the root loci on the real axis, okay. How on the real axis, on what region root locus will lie? First, the entire real axis of the S-plane is occupied by the root locus, okay. Occupied by root locus. If I say root locus, means I am saying either by root locus or by complementary root locus. Complementary root locus means for k value lying between 0 to minus infinity, okay. Now if we take a case for only root locus, then root locus will lie in that region where sum of poles plus zeros is odd. That means if I have pole, 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 0, pole, 0, okay. So if I want to find in what region root locus will lie, so first region is this, in which root locus will lie. Second region will not be this, because the number of poles plus zeros on the right hand side of, I should mention, with sum of poles and zeros on the right hand side is odd. In this case, if I take any point here, the right hand side of this is 1, so number of poles is 1. So in this region root locus will lie. Suppose if I take this region, in this region number of poles plus zeros is equal to 2. So in this region 2, which is an even, so since it is an even, root locus will not lie in this region. Now if we take this region, number of poles 1, 2 and 3, so in this region root locus will lie. Again in this region it will not lie, because the number of poles plus zeros is 4, which is again even, so root locus will not lie. Again in this region the root locus will lie, okay. So if I want to point the root locus, this pole will terminate at this 0, this pole will terminate at this 0, these two poles will come together and they will part, okay, break off. This is a root locus. So number of poles plus zeros must be odd on the right hand side of the region, okay. So where region, what is where we want to find the root locus, in that region it should be odd, okay. In the same thing, if we see the angle contribution by each poles and zeros, then I can write few points. The first one among that is poles and zeros on the real axis to the right of this point. This point means the region where I want to find on the right side of that region that contribute an angle of 180 degree each. Okay. The poles on the left hand side contributes an angle of 0 degree each, and the complex conjugate poles will always contribute an angle of 0 degree. Okay. So will contribute angle 0 or odd multiple of 2 pi, 0 degree each. Okay. Complex conjugate poles will contribute an angle of 0 degree. There is no right hand side or left hand side, complex conjugate will always contribute an angle of 0 degree. Okay. So up to this point we have learned certain basic rules. Now using these basic rules we will try to plot one root locus. Okay. A simple root locus. For a given transfer function, for a given block diagram, okay, I have to draw the root locus. So now if I draw the poles and zeros, can find one pole is at origin, another 0 at -1, another 0 at -2, another pole at -3, another pole at -4. Okay. So the root locus will lie in this region, it will lie in this region, and it will lie in this region. Okay. So it is very clear this pole will terminate to this 0. This pole will terminate to this 0, and the pole at -4 will terminate at infinity. So it is a root locus plot for a given question. Very easy, simple. Such type of questions are asked in GATE exam. Okay. Now the eighth point is in this is breakaway point. What is breakaway point or break-in point? Breakaway point are the point at which the poles come together and goes apart. Okay, the point at which they come together is called the breakaway point, or the point at which they move apart called breakaway or break-in. The point where they're coming in is called break-in point. The point where they're going out is called breakaway point. Okay, to find the breakaway point, we have to find the expression for dk by ds and maximum and equate it to 0. Okay, 1 plus GSHS is equal to 0. If I can write GSHS in terms of numerator and denominator, I can write this as BS upon AS. Okay, so my K will be minus AS upon BS. Finding dk by ds out of this and equating it to 0, I will get AS dot B dash S minus A dash S BS. Find this equation, solve it for the value of S. Okay, those values of S will give me the breakaway point. Now one more problem from the properties which we have completed till now. Suppose the open loop transfer function GS of a unity negative feedback system is given, which is equal to GS equal to K times of S into S plus 4 S square plus 4S plus 20. I repeat again, this is for a unity feedback transfer function. Okay, open loop. This is a open loop transfer. Now for this I need to draw a root locus. First I need to find the poles. Poles of this is S equal to 0, minus 4, and solve this equation equated to 0. I'll get minus 2 plus 4j minus 2 minus 4j. Okay, centroid. Now, centroid is nothing but the intersection of asymptote with real axis. So sum of the poles minus 0. Number of zeros are already 0. So this is equal to 4. So the answer will be minus 2. Okay. Now if I see position of poles and zeros, one at 0, another one at minus 4, and two poles which occurs in complex conjugate pair, they will be minus 2 plus 4j minus 2 minus 4j. Okay. So from the position of poles I can find that my root locus will lie only in this region. Now these two poles will come together and they will break away at some point. Okay. So to find the breakaway point I need to find my k, which is equal to minus s of s plus 4 s square plus 4s plus 20. Okay. Finding dk by ds, from this I will get minus of 4s cube plus, remove this bracket, 24s square plus 72s plus 80. Equating this to 0 and solving, I will get s equal to minus to 1 point and s equal to minus 2 plus minus j 2.45 as another point. So now there will be two breakaway points, one at this point, another one somewhere at this point. Okay. So these two poles will come together. From there they will break away. They will break away at an angle of, but this pole will also come at this point. They will break away at an angle of 90 degree. After meeting at this point, one pole will go here and the pole will go here. Similarly here. Okay. In this case, a centroid is also minus 2. Centroid can be drawn somewhere like this. Asymptotes are drawn somewhere like this. Okay. So this is a root locus plot for the given open loop transfer function for a unity negative feedback system. We have to draw the root locus in a similar manner for the other transfer function. Okay. If it is if it is a negative feedback system, then we have to take care of sign also. Okay. The characteristic equation is very important. That has to be taken care always.